All right, we're here. We're live. My camera fell down. All right, we're here. We're live. My camera is no longer down. Hello, everyone. All right. Let me put these on, mostly to hold my hair back and whatnot. And hello, Stony. All right. I have to say, every day I am more and more like him. Happy New Year, Stony. Right. First time I'm seeing you since the new year. That's true. Doing a compiler today, so that's exciting. That's why I'm saying I'm more and more like this guy. I have my own operating system made from scratch. I'm making my own programming language now with my own compiler. I also think the Pope doesn't know what a compiler is. I also don't like the CIA, but I don't believe they're personally chasing me, so that's cool. Hey, Ice Dave. Also, wait, I realized something yesterday. I just heard him moving around. I thought he was coming, but he's not. He's an independent guy, you know. I realized something yesterday, which is gonna make me apologize to someone with a blue check mark on Twitter, which is something that you should never do. But then again, this is not particularly important. A while ago, someone tweeted a video of mine and mentioned that I made Doom run on my system that I made from scratch, and somebody in the replies said that it wasn't from scratch because I used a toolchain, which I made fun of on stream because it was kind of a ridiculous take. But yesterday, somebody asked me who Terry Davis was, so I pulled up a video of Terry Davis, and I realized that they were actually just referencing him by saying that, because he said he made his own toolchain, so that's why it's completely from scratch. So this person wasn't actually saying, oh, he's not really from scratch if you use the compiler. They were just referencing Terry Davis. So sorry to Mr. Blue Checkmark on Twitter. You still pay for Twitter, which is embarrassing, but sorry for thinking that you are... that you have that opinion when really you were just making a joke that I didn't understand. Let me see if I can get him here. Jester. Nope. He's an independent guy. He is, you think you can just call him whenever you want? Like, that's not how it works. Jester. Seriously? Jester, this is embarrassing. Please come. Alright, he's coming. How you doing, buddy? Dog treat redemption? I still don't have that. Pretty much the only thing I have is text-to-speech, which gets used maybe once a week. Best case scenario. There's Chester. He's arrived. I guess he's no longer super on a diet, but yeah, he doesn't have treats, sorry to say. That's the thing about white dogs, they're very prone to allergies. You have to be very careful. Alright, so maybe it's time to get started on working on Mr. Compiler, so I can say goodbye to GCC. That's actually not really the plan. Short term, that's not the plan. Mid-term, that's not the plan. Long term, maybe. We'll see. Alright. I tried not to work on it off stream because I enjoy doing it on stream, but I did make a couple changes to the compiler. You forgot about your compiler, started making a file format? What? Damn. What file format are you making? Actually, I was interested in seeing how a compiler in Rust was gonna go, but alright. You know, without having to look at the Rust compiler itself, and I don't know about any other Rust based compilers. But this one's made in C. And eventually it'll be made in C Red or Cred or whatever the hell I decide to call this language. Eventually. My operating system is still called Redacted OS, so don't pressure me on names. It's unofficially called Red OS, but I'm pretty sure that's a real thing that already exists, so I cannot really take that name, pretty sure. Red Eléctrica de España. Alright, I live in España, so that's kind of a problem. First off. But I was actually wrong about there being an operating system called Red OS. It is just a it is just a app. What even is it? It's an app to give you information about the electric grid in Spain. I mean, I can think of one reason why that was important somewhere around May, maybe? But yeah. Not right now. Red OS is a Linux distribution created in Russia. Alright, that didn't come up. But there is an operating system called Red OS. What is that picture? Or they're dancing, okay. They're dancing. This was either some like deep web shit or dancing. Turns out it's dancing. One of the pack. Wait, did you say what the format is? Oh, container format. Okay. For games to group assets together into a single file. Oh, nice. Nice. Are you also doing it on Rust? Is that that feels like a good, interesting thing. What? North Korea what? North Korea has their own operating system, which is also a Linux distro, but that one's called Red Star OS. It looks like Mac OS, original Mac OS 10. Well, I guess it's not called Mac OS 10 anymore. Now it's 26. Yeah, it looks like Mac OS. I'm assuming this is what it still looks like. IDK, never used it. Samsung means star. Oh, does it? Solid glass. Actually, it's based off of Aqua, I guess, which is also what liquid glass is based off. Detected English. I know that that's not how you write Korean, but yeah, I don't know about this. I don't know how to do it without writing actual Korean characters. Is it open source? Red Star is based off of Linux, and so is Red OS. So I guess they all are. Imagine getting screenshotted every 5 minutes. Boy, do I have the operating system for you. You can see the smile on my face, right? Boy, do I have the operating system for you. Just saying. It's amazing how many things we will blame on so-called communist and socialist regimes, and then we have that. According to Samsung's founder, the meaning of the Korean hanja Samsung is 3 stars. I see. Yeah, Recall, okay, that's true. Recall doesn't take a screenshot every 5 minutes. It takes a screenshot every 10 seconds, I believe it is. But yeah. Yeah, no, North Korea wouldn't do that. The United States would do that. Not North Korea. I'm laughing so I don't cry. I'm also crying a little bit. Wait, this is a different one, right? This is not the Red OS that we saw in... Well, this is Red Star. This one. Or is it? Well, either way, the point of this is I can't call my operating system just Red OS because that name is very much taken. 3 times, it seems. 4 times? Or is this the actual Russian distro? Nope. Yeah, the name's a little bit taken. Just a little bit. This looks cool though. But it's HTML and JavaScript. Alright, so logically I have to call it Blue OS. Alright, I was also doing music with Strudel. I have to say I really enjoyed doing that. And I've been doing it a little bit more in my free time. Samtaesung means 3 huge stars in Korean. It is a North Korean brand and company that specifically refers to honor the 3 stars of the nation's leadership. Are you serious? That cannot be real. It says here that it's a fast food chain based in Pyongyang, North Korea. Alright. Anyway. Back to the compiler. Alright, so I've done a few things in it. When I left it last time, the compiler had just a very simple... wait, hold on, let me see the video before I actually start. Oh! North Korea's illegal smartphones. Interesting. I've seen people checking out Red Star OS, but not this. Not gonna watch it right now though. That's interesting though. Do they actually take a screenshot of your screen every randomly like that? Because I can imagine that. Oh, also I saw somebody asking about window manager. I'm gonna keep doing that. I did fix a glitch that there was that made it kind of difficult to use, so I fixed that. But I haven't expanded it more. I will do it on you know on stream a little bit more probably these days. Add recall to your OS. I have to admit, the conclusion that we should get from this is it's incredible how much they're spying on literally every single one of us. Like, it's kind of inescapable. Well, okay, you can use Linux, but not Red Star OS. Or, you know, just not use Windows or Red Star OS. But, like, Jesus Christ. Hey, Arctic. Okay, this is just the operating system, so let me close that. This is the compiler itself. Okay. All right, so last I left off, we made a little bit of a parser for this very simple language. It's not even C technically. Well, it is C, but it's an incredibly small subset of C. It literally is just assignments, or not even assignments, declarations. That's all it's able to really parse. Things like this, and this. This one technically isn't even valid if you think about it, because there is no type called var. Maybe I'll make it valid in my language, but it would be a string in this case, but that's not a thing, so to speak. But it's still valid. The syntax of the program is valid. The semantics of it are not, which means the actual characters are valid, even though the meaning is not. In the same way that stringing random English words together doesn't make a coherent sentence, but it does. It is a English sentence, just a nonsensical one. Arena allocator? I probably should at some point create one, but no, I don't have one right now.
How is the project going? Or may I say flowing? IDK just be cool and chill like a will comrade XD lol LMAO.
It is going. Researchers found a backdoor into China's firewall and gained some information. Oh, I heard about that. Alright, so the compiler can right now just compile this type of thing. When I left it, if you had a syntax error, it would just run forever, which is not ideal. And it turns out, essentially, when it had a syntax error, it was just, spoiler alert, right there. It was just like trying to parse until it ran into the syntax error. Then it went back to the beginning and it tried again, which you don't want. So if you fail, you break out of the loop, and that's it. So I fixed that. And also, I noticed that if you have a syntax error, right, for example, like this, then the parser will get to this point, it will try to parse this character, and it will fail, at which point it will fail parsing this entire line, at which point it will fail parsing the entire program. That is a syntax error, and you failed. But by keeping track of how far we actually got in parsing in the scanner, which is the underlying structure that powers the tokenizer that then powers the parser, by just keeping track of how far that actually got into the string, into reading the string, you can know exactly where the program failed. So if I try to compile this right now, I first need to update the operating system with the latest changes that I made on there, and recompile its library. And then it should have worked, but it didn't. That's kind of interesting. Yeesh, I've been working on my laptop, so now working on here is not amazing. Another thing is I need to recompile the red build system, because I've also made some changes to it. My local changes would be... What changes? God damn it. Alright. Let me fix all of this real quick. That's the problem with working with multiple computers. You gotta sync everything up. Then again, I refuse to use Linux any more than strictly necessary. Oh, I see. I can just overwrite that. Thank you. All right, you should be able to pull now. What more changes do you have? I see. You're done now, right? Okay. We should be able to go into source and bootstrap. I committed something here that I shouldn't have. Even though this thing should be able to compile itself, I still have a simple script to do that for me. But you did it, right? No format invalid specifier? Is that not valid? Or whatever, that doesn't matter. The point is that compiled, and this compiled, and segmentation fault. Amazing. Ugh. All right, so I have to fix this before I actually get started. Let me see. Do I have any... changes that I didn't commit? Doesn't seem like I do. In the build system, no, not really. Wait, this library though might have some changes. All right, so I have to recompile like 50 million projects in order to get all of this to work. All right, so that's one. And then... okay. It's actually missing a commit. Okay, and that failed why exactly? Multiple definitions of main. Well, that would be because you're ignoring me, isn't it? All right, I also added to my build system the ability to read a build.config file inside of the project to configure it a little bit. Because I wanted to ignore this file, which I'll talk about once I get all of this to work. But it isn't ignoring it, which means that it tries to compile this file, which is a separate program, and so it fails, and so it cannot compile, which is great. Wrong symbol of type 18. Damn it. Okay. This did compile, and I do have the latest changes on it. And I've also pushed the latest changes. Yes, I did. Hi, Jester. Hello. Okay, complaints about this because I added this no format invalid specifier, but it clearly doesn't work on CC, so maybe I'll have to fix that. This works on Mac, so how can you find 0 results? I understand that maybe it doesn't work with this compiler, but it does work on Mac, so there should be some results. You know, if you hadn't completely nerfed your search engine. Oh, look at that, there are results. You just vibe coded your entire search engine, didn't you? Although it doesn't seem anything particularly useful, but that's not super important right now. Okay, so this error, wrong symbol, comes from the build system. Really, it comes from the shared library. So actually, I would have found it in the other project. Okay, there's something wrong here. It says wrong symbol, and it should tell me what the symbol is that it was unable to parse, but then when you look here, it's just empty. Of type 18, and symbol of type 18 is a new line. I see, so maybe the problem is just that I did this. No, that's still happening. I put a comma at the end. I like having a build system, but once you have your own build system, your own operating system, your own compiler, you know, things can break like this. And it gets in the way of what you actually want to do. Which is really annoying because it works, except when it doesn't. Again, you're detecting a wrong symbol here. It's not a new line too. Even though it says it's a new line, it doesn't feel like a new line. But, okay, that report of wrong symbol comes from this CSV, or comma separated value, scanner that I created. That shouldn't actually detect new lines. That's kind of the problem here. I modified my tokenizer to be able to recognize new lines, but the default behavior is that it doesn't recognize new lines, so it just skips them entirely, and it sees the entire text as no spaces, no new lines, no tabs, none of that. All of that is ignored, but clearly that's not working, because it is finding a new line and complaining about it when it really shouldn't be doing that. Uninitialized memory, that's the problem. God, I hate Linux. What can I say? In what world is it reasonable that... Well, this is not malloc even, is it? Uninitialized memory is so annoying. That's the real issue here. It's uninitialized memory. Course on how to build compilers? Not really. They were talking about books on my Discord server, and I think they actually published some a Discord server dedicated to making compilers, and also a few resources for that. But honestly, I haven't checked it out. I asked them to create a thread so that it could be there for reference, but I haven't looked at it. Confession time, I haven't looked at it. All right, I think it compiles now. Yes. Okay. Amazing. We can go back to talking about the compiler, which is what I was doing before when this entire thing interrupted me. Okay. So, when you have code that looks like this, right? So I have this invalid code. It's technically not invalid if you think about it, because you could write -1 plus 0, which means you can also write +1 plus 0. But my current tokenizer considers this to be an error, and as such, it can recognize negative numbers. That's the funny thing. If I make it a negative number, no, it still fails. That's interesting. So it cannot recognize. All right, there it is. Either way, it's able to scan this thing. The error message, well, their message here is not particularly helpful. It just says string scanned. But what it means is it was able to parse correctly. This 1 means that it was able to parse correctly. The 0 means it failed at parsing. And it tells me exactly where it fails, position 9. If we go back to here, we are currently on line 1, position 9. That is visible on the stream. Yes. So it knows where your syntax error is. The problem with this is that it does not have a concept of lines. And so it tells me at position 34. And position 34 is technically correct, because it's here, 34 characters. But it's spread out across 3 lines. So we're actually on line 3, character 10. So I should do a little bit of calculation to, instead of just telling you on character 34, tell you line 3, character 10. Or column 10, if you want to be correct about it. But to be honest, not a huge deal right now, because we're in a very highly controlled environment where pretty much any syntax error is intentional. So it is a thing that I'm going to have to do, but it is not a thing that I care about right now. However, all right, the spoiler from before. Currently, we're able to parse only programs that look like this. Programs is a strong word, actually. We're able to parse declarations, essentially creating new variables. That is the only thing that we're able to parse, and then we don't do anything with it. The compiler is just like, well, you're declaring 4 variables. Good for you, buddy. And that's it. Then it ends. It doesn't do anything else besides that. But it is able to detect that you correctly wrote 4 assignments or more, as many as you want. And in order to do that, it has all of this. So it has 49 lines, which is not a lot, but it can get out of control fast. Because, of course, that's this very simple syntax. We want to expand the syntax of my program, at the very least, to be able to compile something usable. And so this is going to get out of hand fast. Not only that, but there's something that really bothers me about it, and it's the fact that it's using these hard-coded arrays, and in so doing, it also has... they're actually not entirely arrays, they're also types, structs, really, but they use arrays. And they have how many items are inside. So we have 2 items here, and then we have 2 hard-coded here. And for example, this rule here has 3 possibilities, but I've currently only implemented 1. But it's very common for me to write 3 here, because there are actually 3. But then, because these 2 are disabled, I disable them, I comment them out, and then this stays as 3, and that creates problems. And also, most compilers aren't really written by hand. You would use... not compilers, most parsers are not really written by hand. You would use a syntax like this one, which has a name. Maybe I have it opened here somewhere. the extended Bacchus-Naur form. Ish, because my implementation of it is very simplistic. But a syntax that looks a little something like this. And from that, you generate the parser. So you don't even write the parser yourself, you would more so generate it. And of course, if I have this, it's because I have written a very simple parser generator. It's incredibly simple. It's 70 lines of code. And hi Kai. It's written in the same way that the main compiler itself, the parser itself, is written. So it uses the same things: a scanner, tokenizer, a token stream. Here it is, token stream. It uses the same syntax as before. It's just much more specialized. Whereas I made my parser able to parse whatever you put into this array, this parser is hard-coded. It's like, okay, I expect to find an identifier. After that identifier, I expect to find an arrow, right? So an identifier followed by an arrow, followed by this thing right here. And that's pretty much how it's done hard-coded. I expect to find an identifier followed by the arrow, and then I'm going to parse the rule. And then this is also why I added parsing new lines, because new lines can also be a token. This one doesn't use semicolons. A rule ends where there's a new line. The first parser I did write myself, but it is based off of that array. And now I wrote this very simple parser. That's not what it's actually called, but that's what I'm going to be calling it. That simply parses these rules. And again, it's done in a very hard-coded way. You want to find an identifier, you want to find an arrow, then you want to find an operator, and that operator has to be this symbol right here. And if you find a new line, you're done. And anything that you find in between is an actual rule. And yeah, right now the way that I did it also is very hard-coded, that rules are lowercase and tokens are uppercase. So whenever you find identifier all uppercase like this, it means you expect to read a token of type identifier. Where you write something like expression, you expect to find something that matches this rule right here. Not really C killer. My plan is to just expand C with the things that I need. But I guess there are two ways of writing a parser. One of them is by writing it manually. The other one is by having a generator write it for you. And then that generator can be done with something like this. So I can easily alter what my program looks like by just changing this, right? And I just change the syntax of my program. Or it can be like this one, where it's kind of more hard-coded, but it doesn't rely on things like arrays and all that stuff. That's a little bit weird. But this compiler and this compiler are very similar to each other. Except this one, that's the one that parses this, is just a highly specialized compiler specifically for this language. Whereas this one can parse any language. And I guess more so a compiler or a parser generator would really work like this, in which it hard codes the rules instead of building arrays and whatnot. But mine, what it does right now is just let me see if it works. It doesn't, because it is made for compiling for Mac. Build system's not quite ready yet, so Seg fault. Amazing. That's gonna be a problem. God damn it. That is definitely going to be a problem. Although, I have to admit, I don't understand what your problem is with this. Alright, we're gonna have to do more debugging. Everything's from scratch, though. Which is why it's all failing today. But anyway, the point is, I have a parser for this grammar, which then produces my actual parser for my program. I figured I would build this so that today we could have something that is a little bit Turing complete. And I'll talk about it when this error is fixed, because I've been streaming for 45 minutes and all I've done is fix errors. I love coding. It's amazing sometimes. Alright, it's seg faulted. On line 3, which means it's seg faulted in running the code. And I hope that was correct. That was not correct. This is not the syntax, is it? Is this the syntax? This is the syntax. And it received signal sig-sev, sig-seg-v segmentation fault. Oh, wait. No, okay, I understand what's happening. Hold on. The problem with this is that I didn't define a entry point, right? Which I also don't do here. And somehow here it works. All right, first off, shell script. Second, it's missing this rule, which is not helpful. And then it is including this and this libraries. It is parsing rule parser.c. It is linking the lib shared from the OS, redxlib, raylib. Although it technically doesn't need raylib, but redxlib does it, so it's okay. And produces into rulegen. And then that should work. Either this was missing or something else is happening. Hey, MX. Yeah, no, there's something else happening. But the fact that it tells me that it crashed at 0000001, I'm assuming that just means that I need to put an entry point. What I'm surprised about is that this script doesn't need it. That's a little weird. When this program doesn't have a start function either. It just has a main function, right? And so does this one. So I really don't understand what the difference is between those two. But I do believe that is actually the problem. And actually, this is what I need to add. So what I've done already is absolutely nothing. Now, it's still seg fault. But it's a different one this time. So, GDB, your time to shine. Allegedly. Excuse me? Here? What? What does this mean? You failed because you initialized a variable? That is a problem. Why exactly? This is so weird. That is, hmm. Sure, buddy. GDB is so helpful. I love it so much. What is the problem? Like, what are you telling me with this actually? Segmentation fault because I initialized a variable? Make it make sense. Yeah, it keeps seg faulting. In tokenizer make on line 64. But why? Is it because there's no start function, so it's not setting up the stack, which is apparently the program's responsibility to do? Is that what's happening? Because I feel like the start function in C is usually inserted by the compiler, but the command to build the program is this one. No. It's this one. Well, no std lib freestanding is wrong, so yeah, kind of. That was it. Nope, that was not it. All it did was just bring in more warnings that weren't there before. STDC99, this WLE main, D cross, compile the rule parser with all of these libraries into rulegen, then make rulegen executable and then run it. All right, GDB, you have any new information for me? Exactly the same thing. From main, line 48. I genuinely don't understand what the fuck it's talking about, to be completely honest with you. Then again, I don't even know how to debug this. Not super familiar with GDB. I kind of hate it. What little I know about it, I hate. I mean, if I remove this, which is a stupid thing, but if I remove that, it goes a little further this time, which is absolutely ridiculous. There's something weird happening here. I just don't understand what it is. What are you going to tell me that it is now? Why does it keep seg faulting when I initialize a variable? God, I'm Googling something incredibly generic. This is not gonna help. This does not help. Why would I need to initialize it with 0? Keep in mind the other program works just fine. So, Well, the other program is being compiled by my build system, which internally uses not GDB, GCC, but am I forgetting some rule? Like this works in the actual compiler, but it doesn't work in the rule parser. The only difference is that the actual compiler is being compiled by my build system. Which, by the way, I have this script over here. Before I updated the build system to be configurable, I created this. It also segfaults. Yep. Okay. So something GCC cross WL start group, then all of this, right? All of these inclusions, as well as combining main.c, redxlib, libraylib, lm, lc, detour, and that's all it's able to print. But shouldn't be printing a whole lot after that. Wait, besides the fact that, again, you're also compiling with no stdlib and freestanding, which you shouldn't. Wait, I also just realized I'm linking my game engine into this because I haven't made it so that you can configure your project's includes and links just yet. So it's all hard-coded. But the game engine isn't fixing this, I hope. I'm a little bit surprised. Alright, let me see what the build system is doing. WLE main is actually only needed by when building for redacted OS. It's not for building here. When you're building in Linux, all you do is add this start group thing. I never even end it. And then the compilation with GCC happens. With the compiler, preprocessor flags data, compiler flag data, link flag data includes sources, linked libraries, and output. That is it. So the thing I'm thinking of is maybe I'm compiling with C99, whereas technically my system is not. Wait, hold on. It's Bootstrap. Fuck, okay. Wait, so C99 doesn't allow that? If I'm searching for something like this very explicitly and then something like this very explicitly, how is your search engine so bad that it is incapable of finding something? So is that not valid syntax in C99? Because I've been using it all over my operating system, in which I explicitly compile with C99, and it's been working fine. But that is the issue. And also, what's the default version that it's using? How can I know that? C11. Yeah, well, Google is completely useless, so that's not helping. Would this be valid syntax that C99 would enjoy? Well, I guess to find out. Nope. That's still false. Damn. I mean, I'll have to look into it externally, like eventually, but I know I need to recompile half the system. No, come on, you still segfaulting? Are you serious? I removed it. What's the problem now? Well, this is not needed anymore. Right, but I removed that option. I also removed it off of here, and here it works fine. Wait. Yeah, this compiles fine though, but this one doesn't. Oh, now it does. All right. So here's the generator that simply outputs the array that I use here based off of these rules. And we're going to be able to use this to expand the syntax a little bit, but I'll do that after a break because it took me an hour to just get my program to work. Okay, so I'm back. And I added this again just to see the error one more time. Which error? Where did it go? Is it gone because of this now? Nope. It's just gone. It's just gone. Just give me a couple months to do the compiler and I won't have to deal with this again. This is why I want to have control over every aspect. So otherwise you have to deal with bullshit like this. Absolutely incredible. But anyway, this make rules command creates, parses this and creates an array. It literally just prints it to the console, right? It's an incredibly simple program, but it prints this array, which I can then just copy, copy, and paste into here. And it's exactly the same, almost, with the difference that these two are here. But I had already done that, which is why there are no changes. But this means that I can easily just AG Studios. There. Write to this file, and that way alter my syntax of my language. I don't know if a bug suddenly disappearing on learning why it's good or bad. I'm gonna go with mostly it's bad, but it tends to not be a problem until later. And honestly, works now. Yeah, there we have that, and then I can do red build cross, and I can do cred.elf, and I'm able to compile my program. Hey, Curse Devil. Sorry you had to debug CPP. Sad to hear that. All right, but the point is, after all of that, we are able to alter the syntax of my program by just altering this very simple config file. Because now I have two parsers, two compilers even, if you think about it, it's technically two compilers. This one is a compiler that takes this as an input and produces this as an output. Then this one takes, well, technically it takes this as an input as well, but mainly it takes this as an input, and then it produces nothing as an output. It just gives you a thumbs up, because it needs to produce a little bit more than that. So, when you think about it that way, it can be kind of interesting to consider that both of them are essentially doing the same thing. They're reading text, any arbitrary text, checking if it's syntactically correct. They could also check if they're semantically correct, which is to say, if you're referencing a rule or a token here, right? If I do this, what is test? It's not a rule that I declared here. It's not a token. It doesn't exist. So technically it's not right. So you could do some semantic analysis on that too. You know, to know that all variables exist, that what you're writing makes sense. Like I explained before, I can just chain a bunch of random English words together, and it's syntactically correct, but it doesn't make sense. It's not semantically correct. So the main steps of compilation, do I have that little graph that simply helped me explain that? I have a million tabs open. Yeah. Well, not really. The point is, both of them are the same thing, right? This parser is more hard-coded because it works over this very simple syntax. Technically, the syntax can get a little bit more complex than this, but I didn't bother with that. Not yet, anyway. So yeah, it's a more hard-coded parser. Like I said, it just goes over the specific cases one by one. And so altering or adding new cases means altering these if statements and the switch statement over here, which could also very easily just be an if statement. It actually should be an if statement because it literally is just based off of one rule. So could do this. And then this. Right? So if I play my cards right, I might be able to make the parser parse itself and generate itself. But that's really not necessary, but I really wanna see if it works. First off, I should be able to comment these out by just doing this, if I'm not mistaken. And then see if I can make my main parser parse these rules as well. Right? So what do they look like? It's a very simple syntax in which we have the... it's a little bit weird actually because I have to use these names because these are hard-coded as enums here. So I have to use those names specifically, but I think actually those names should be fine. So what does a block look like in this language? It looks like a parser parses the parser. I'm not gonna bother semantically analyzing your sentence to know whether it made sense or not, but I'm just gonna say yes. That's an example of semantic analysis. What he said technically makes sense, or is technically a correct sentence. Is it actually correct in that it accurately conveys the information that of what I'm doing? I'm not sure. I don't want to bother with that. So, what does a block look like? It's funny to declare a syntax using that same syntax. But hey, we're getting a little bit recursive in here. All right, what does it look like is we have an identifier, which is this one, followed by an operator, because this is considered an operator. Now, this is where the semantic analyzer would come in and check if this operator is correct or not, because it has to be this one. It cannot be another one. But because we don't have that yet, that means that technically this is valid syntax, when really it shouldn't be. But again, we'll expand the compiler and make it more correct as we go along. So we expect to find an identifier, followed by an operator, followed by an expression. Okay, and the expression looks like this. It has a one or more identifier. Well, let's say that it has a statement followed by an operator, and that operator is this one, but again, because we are not differentiating between them, it can be anyone. So again, we can parse the if everything goes right, we can parse the syntax correctly. But we can also parse other things that aren't technically correct. And the compiler just doesn't know. So it can be a statement followed by this, followed by another statement, or it can just be a statement. So it can be either this thing or this thing. See what I mean? What I mean when I say it's getting recursive? And what is a statement? Well, it's just identifiers. It's either an identifier followed by a statement or an identifier by itself. That is technically the syntax for the parser. All right, so it generated that, and I can plug that in here, and I can then replace this with this, removing these, and yeesh, I kind of forgot. Yeah, hold on. There is one level that I forgot. This can parse one rule, but we need to parse multiple rules. In order to parse multiple rules, we need to parse as declaration. Again, I have to use the same names that I'm using anywhere else. New line, declaration, or declaration. And declaration becomes the rule itself. Whereas rule used to be block, now it's declaration. All right, so that is the correct syntax. To parse multiple ones anyway. And I'm not sure, that wasn't supposed to be there. I'm not sure if this is new line enabled or not. It is not actually. So I need to make it new line sensitive by doing tk parse new line true. And that will allow to create the new line token, which we expect to find. So we'll do red build cross, and we'll do cred.elf, and it found a syntax error on line 53. And this is where it gets a little bit complicated, because what is line 53 exactly? Here. This is getting too recursive for my liking, I'm not gonna lie. This is not even recursive anymore, it's just inception, and at that point you're just give up. It tells me it found a syntax error, but I actually disabled most of the errors that it produces. The like... Yeah, here. I can just do this. Is that how you do that? Or just this, actually? That's how you do that, okay. Red build cross, cred.elf, and now it tells me exactly what's going on. Ran out of options to parse 0, so it failed. The problem is reading this to understand exactly what failed can be a pain in the ass because there's so much happening. It parses the word block. It parses this. It parses statement. Right? Yeah. Okay. It parses another statement. All right, that makes sense. Hold on. it parses this, which is declaration, new line declaration, identifier, operator, expression. That's what it's parsing. Yeah, I'm getting so confused by this. All right, you know what? Let's not waste too much time doing this. That's clearly I'm not ready for this. Let's just bring it back to how it was. Nice and easy. And actually work on expanding the actual programming language and not in making the parser parse itself. Or generate itself, kind of, actually. All right, so we're back to sanity, I believe. I do need to remove these manually. BNF, but with a different form. It is BNF, but with a different form. That's pretty much what I was doing. To be fair, I didn't consult what BNF actually looks like. Because it has an equal sign. It doesn't have an arrow. But it uses semicolons at the end? I added new line parsing specifically so I didn't have semicolons, but apparently uses semicolons. All right, so like I said, it is that. I just didn't bother with actually looking up the syntax. I was just like, yeah, I'll just make it this. But yeah, I guess once I expand the parser a little bit and make it like actually tell me what's wrong, I will be able to understand a little bit more. And I'll be able to make it parse itself. But the whole point of that experiment, which kind of failed, but I kind of expected it to fail in a way, is to prove the point that this and this are both parsers and they're both doing the same thing. This one just generates code for this one, but because they're both doing the same thing, they're kind of interchangeable. It failed because they're not super correct and super stable, but eventually we'll be able to parse itself. The thing is that the rule parser is more advanced because it actually outputs something useful, which is it turns this into this. So not only is it parsing, it is also generating an output. Whereas this one is just giving you a thumbs up. But that output that it generates, it's very hacked together. It's literally just print statements, and actually print statements with a bunch of T's for indentation and whatnot. It's kind of ugly. Eventually I'll make a proper code generator, and I will expand this one to have a proper code generator, as well as semantic analysis and all that stuff. And eventually, like I said, there's a chance that because they're doing the same thing, I will be able to just merge them into one. So the compiler will be able to compile its own rules and then use those to compile itself. But it's definitely not a priority. But maybe it's time that we do something useful with the actual code that we actually parse, which is, hold on, this one. And in order to do that, first I think we should expand the type of code that we're actually parsing. And second, we need to keep track of the code that we're actually parsing. So right now we can only parse this, only declarations. And if you look at the rules, this is the important one, only declarations. In the actual rules, I also put in assignments and function calls, but there is a concept of Turing completeness, which is named after the Turing machine that is, I believe, a hypothetical machine created, well, thought of by Alan Turing. He is pretty much a British mathematician that was the single reason why the Allies won World War II. As a reward, the UK government, in its infinite wisdom, chemically castrated him and led to his suicide. So, great job on that one. But before they did that to him, he did create the concept of a Turing machine, which is kind of a tape machine, which just has a bunch of, let me see if it has some useful little graphs or something. It's essentially a tape machine. The tape is divided into cells, and it has a head that is capable of reading and writing symbols to the tape. It also has a state and instructions. And technically, it is capable of implementing any algorithm out there, which means it can technically do any program out there. Oh, you're the one who posted the compiler stuff. Yeah, I have it there in case I need it, but mostly I'm just going by vibes alone, which is not the same as vibe coding, although I want to reclaim that term, but no. So yeah, this is a hypothetical thing, but from it, we have the concept of Turing completeness, which simply indicates that a programming language, in this case, is capable of running any program out there, if you will. That is to say, if I want my programming language to do anything useful, it needs to be Turing complete. Which is actually kind of somewhat simple. Yeah, no, I'm super tired of vibe coders. For example, I don't know, let me write a simple C function, right? Directly in the compiler code. And then let's say that I want to draw to the screen. So usually the code will look like this. Say that we're drawing to a 100 by 100 grid. It will look like this, and then same thing on the x-axis. And then, I don't know, let's say that we have, I'm gonna declare as extern just so that it's all syntactically correct, even though it won't actually do anything. Let's call it a uint32 array called screen, and we'll put 100 by 100 in it. And that's it. It's not actually connected to anything, but we can just do something like this. And then draw a color in here. And we're going to make it green, for example. Right, so this is C syntax for drawing to a screen, a solid green color where the screen is an array. So C is obviously Turing complete, but do I need a for statement in my program in order to make it run? No, you don't need a for statement. Because this can be written as this. You have to have a y variable, right? You have to increment the y variable. And then you have to check that the y variable is... actually, you can do it with, for example, a while loop. And then... which actually some people do this. They don't write for loops, they just write while loops with a declaration outside and this. But a for loop is just doing this in one line. So it's a little bit more convenient, but it is pretty much just doing that. But what if I don't even have... also, same thing would happen here, by the way. Like, I just don't want to rewrite it every time, but yeah. Actually, for the sake of simplicity, let's say that we're only drawn in one line. So there's no X. It's just drawing to a vertical. What if I don't have a while loop? Well, C actually has go-tos, which people hate, but they're useful. So I can put a label here called draw, and then if y is smaller than 100, go to draw. And otherwise, it will just print. Right? And I could even technically run this if I wanted to. I just don't want to bother. For that matter, do I need the array initializer thing? And this is actually something that I learned recently. Kind of very dumb, but I believe this is technically valid syntax. This is valid syntax in C. Jesus Christ. That is horrifying. But why is this valid syntax in C? Because what we're doing here is essentially just this. Except, you know, you need to cast if you want it to work, because the compiler doesn't like that, but yeah, that's all we're doing. Do I need increments? Not really, I can just do this. So, for that matter, do I need this? Technically, no. In order to make a language Turing complete, you don't need to have things like for loops, while loops, all of these things. At the very, very minimum, you need to be able to write to memory, like we're doing here, which we're also doing here, and also here, and read from memory. Also do comparisons. And jumps. If I'm not mistaken, that's technically all you need. Now, the Turing machine, if I'm not mistaken, maybe I'm mistaken about this, to be honest, but if I'm not mistaken, the Turing machine, like I said, it operates over a tape, and so it is able to move forward and backwards. Whereas our modern computers just go to a specific address. It can be the next address after the one that you're currently at, or the previous one, but it can also be a completely different address. This is because we have random access memory, or RAM. But again, even that is just kind of syntactic sugar on top of a Turing machine, if you will. Whereas to go from memory address 1 to memory address 100 in a Turing machine, you increment 100 times. In a real computer, you just jump to 100. But here we're essentially just incrementing the program counter, or decrementing the program counter. In this case, we're decrementing it. It's the same as saying, we don't even need labels technically. You can just go like this, which is how an ELF file and how assembly actually handles these types of things. So we would need some way of writing to memory, ideally also doing some sort of operation, not just writing random variables like we're doing here. Here we're writing a variable, sure, but here we're also writing a hard-coded variable, but here we're actually reading from memory, incrementing, and then writing to memory. Here we're doing a comparison, and then we're doing a goto. But technically, this is all you need in order to be able to implement anything. writing to memory, reading from memory, comparisons, and jumps. If you have that, it can probably run Doom. But ideally, you would have a little bit more than that. But, you know, it would be nice to be able to have some sort of very basic program like that. And right now we have one instruction, technically, which is writing to memory in the sense of a declaration. We don't have jumps. And we don't have conditionals. And we technically do have reading from memory because this is valid syntax. And what this means is the value of A, add the value of B to it, and write that into C. So actually that increment that I was doing before, you can just do it as C equals C plus 1, which is not super valid syntax in my program right now because it would need to have this at the beginning, but it is technically doable. So we could use some jumps and some conditionals. That is an if statement and a function call. There's also gotos, like I said, and I do plan on using gotos at some point or another. People complain that they make execution of a program hard to read and so more error prone and whatnot, but to be fair, they also make they're also useful. And I want to implement some sort of defer instruction, and if I want to implement some sort of defer instruction, then I have to have gotos in my program, in my language. Which I wonder why my screen randomly glitches sometimes. I've noticed that a few times, but I don't understand why it happens. Oh well. There's actually no overlays. Oh, besides the chat overlay. Yeah, so there is an overlay, never mind. But yeah, anyway, OBS is glitching. What else is new? Okay. Before I do any of that, I just realized the heater is not on and it's really, really cold in here, so give me a second. Alright, it's gonna take about a year to heat up this entire room and make it nice. I'll probably end the stream before then. But, hey, better late than never, I guess. I'll also close the door. Alright. So, I'm actually going a little bit further in that I have declarations, assignments, function calls. So I already have those. Technically, you don't need both declarations and assignments, but yeah, it's kind of nice to have. And then on top of that, I guess we also want conditionals. Right? So, like I said, the rules are declared in an array here. So I need to put this new one in an array. I call it conditional, so I'm going to call it conditional. And now I have to implement the assignment, function call, and conditional. All right, so the assignment is easy because it's the same as a declaration, except it doesn't have the type at the beginning. So we just remove this identifier. That is pretty much the only difference between them. And to test if it works, I am just going to put in an assignment like that. All right, which is my increment from before. All right. If I do want it to work though, I'm gonna get rid of these rules real quick. And I'm gonna make these const Just because I think otherwise it's gonna fail to compile. Unrecognized grammar token E. What's E? What are you talking about? You literally parsed them all too. Oh, wait. A double new line is not allowed. Alright. It was missing the expression. That part didn't get parsed. Okay, I get it. Alright, so we have this. And I kind of hate that I have to like write it in manually like this. It would be nicer if it could just write to file, but oh well. And it finds a syntax error on line 29. Well, not on line 29, on character 29. That's a little bit weird. I think I need to make this wall of text over here a little bit more readable if I want to understand what is going on. So should be able to get rid of some of these messages entirely. Simplify some of these. Okay, so I want to put the current rule here and the option. If you succeeded, you don't need to tell me that. You don't need to tell me what token you're currently evaluating. You don't need to tell me how many options there are. All right, so hopefully that produces a little bit cleaner output. And I can see what's happening a little bit better, but it's not going to be easy. Probably the best thing I can do right now is... Wait, no. These are my rules. This is my language. See how far I can take it. Hey, goldfish. Okay. This one actually succeeded, interestingly enough. This one I believe did not. No, still did. Still did. But this one fails. By any chance, is this syntax wrong or something? Nope. Position 31. Just like it managed to parse up to here and then it fails. After that point. Not sure if you're gonna be able to share anything on here. You can share on Discord maybe. If it's a link, I don't think you can. Not on YouTube. On Twitch you should be able to. No, this fails. This succeeds. All right. How? This is so hard to read. Okay, I have an idea. Let's say that I define a structured log class like this. This is not the best idea. Never mind. I want to create a proper logger type of thing. But I think for the time being, it's not the best idea to bother with that. But instead, here's what I can do. And just put a bunch of these in a character indent, right? And then I can define current indent as indent plus, well, first off, how many characters are in this? 1, 2, 3, 4, 5, 6. Indent level. Or 6 minus indent level, actually, is the correct thing. No, indent level. Yeah, no, hold on. This should be 0. That's the thing. 6 minus indent level. There we go. Shared enough topic? I'll take a look in a second. All right, let me see if this works. It would be interesting. At the beginning of each of these logs that I'm interested in, I will put the current indent, which should indent by a certain amount of tabs. And I actually created an indent level, but I have a parser depth, which is the same thing. No, I shouldn't be putting spaces. All right, I believe that's it, but if I just run it like that, it's not going to have any change, but it's also not going to crash, so that's good. Pretty sure I can just use the parser depth, and there is a maximum parse depth of 16. So maybe that's 12, that's 18, that's 16. It's a bit overkill, but hey. Max parse depth. There we go. Hey. All right. So that should make it a lot easier to read what's going on here. And see exactly why it is not failing right now. Kind of interesting. Yeah, this doesn't fail. Okay, yeah. This doesn't fail, but this does. Yeah. All right. Okay. So we can see that we're trying to parse rule 000, which stands for, actually, while I'm at it, structure these logs a little better. All right. We start trying to parse 000, which is this rule, this option, this statement. Of course, it has to parse a statement, which itself has a subrule assignment. An assignment has identifier assign. All right, I can remove this log as well. I want to make it as small as possible because I'm probably going to be doing this a whole bunch. So I want to make these logs as readable as possible. All right. Rule 0 is block, has rule statement, which has rule 2 declaration. Right, so it is trying to parse a declaration. What does a declaration look like? It looks like identifier, identifier, equal sign, so assign, followed by an expression, which, spoiler alert, it is able to parse correctly, so then it moves to the next one, token. So the indentation actually allows me to skip reading all that, so that's pretty cool. So it parsed the first statement, and now it tries to parse the next element, which is this statement right here, and it fails, and that's what's causing the issue. It then tries again by parsing just one statement, which is it is able to do here, but there's nothing else to match after that, and there's still characters to read, so it's like, hey, something went wrong here. So okay, I understand why it fails. What I don't understand is why this second one fails. Because it fails to match token 2, it found 18 instead. And I'm not gonna lie, I wish I had an enum to string type of thing. Which my language will have, but it currently doesn't have. Failed to match token 2, found 18. So token 2 is identifier, and it says that it found 18 instead, which is new line. Oh wait, I made it new line. Oh my god. Oh, that's the reason it's failing. I made it new line sensitive, because for the other thing that made sense, but now it doesn't anymore. And now it parses correctly. Cool. Well, I'm kind of glad I took that little detour of adding the indenting, because it makes it so much easier to read what is going on. And I was actually able to understand the issue somewhat quickly. Probably even quicker if I hadn't been explaining the whole process. But yeah, I like that I added this, even though it is very hacked together. But as a matter of fact, the rule parser, like when it generates code, it's kind of doing the same thing, just much more hacked together. So in terms of hacking together, this one's pretty good, not gonna lie. Okay, so it works again. It was able to parse, whoops, this correctly. So now we have also assignments. Cool. And just to make sure that everything works, we're going to declare a variable like this. And you know what? We can do a little bit of cursed JavaScript-like, because we don't have semantic analysis yet. Trust me, I do plan on stopping this eventually, but right now it's syntactically valid. And that's okay. Go crazy for now. All right. So it works pretty well, I think. We can introduce the next one, which is a function call. What does a function call look like? Well, it begins with an identifier. It is then followed by a left parenthesis, which is called leparen. Spoiler alert, there's going to be a right parent. But in between them, there's going to be arguments. Argument. No S. That's pretty much what every function call is going to look like, I believe. There isn't anything particularly complex about the function call besides the arguments themselves. So about the arguments. What do they look like? Well, they are an expression followed by a comma, which is just comma, followed by another expression, or just an expression by itself. All right. Are we able to parse function calls? This is a const expression. This is an identifier expression, and there's a comma in between them. Nope. Just making sure that I did do it correctly. Do a little bit of manual parsing here. Identifier, left parentheses, expression const, yep, comma, yep, expression identifier, yep, right parenthesis, yep, semicolon is not actually part of it. Okay, I see. You have to manually specify that the semicolon goes at the end. It still fails. I haven't done anything weird yet with it. Okay, so it still fails here, and there's a lot less stuff that we can see. So that's pretty cool. I'm looking specifically for rule func call, which is value 5. So wherever I'm parsing rule 5, I'm not... Oh, wait, hold on. This is kind of not automatic. You have to manually copy and paste it. If you don't do that, a language cannot possibly parse things that you haven't told it about. I mean, the parser cannot possibly parse things that you haven't told it about. And now it is able to. All right, we can bring in our entire syntax, and there we have it. Cool. That was surprisingly easy. So that leaves me with the last and possibly most complex of these, which is the conditional. All right. What is a conditional? It is this. Right? So it's an identifier followed by a left parenthesis. Eventually there will be a right parenthesis. And see, this is where this syntax is a little bit limited because I'm saying identifier, but identifier is not really super helpful. It would be easier if I could do something like this or this to specify I want an identifier and I want it to have this. But again, my my parser generator is a little bit limited right now, and I'm kind of okay with that. I'm okay with parsing just if it's not an if statement. Whatever. Just as long as it doesn't generate any kind of ambiguity, which so far I don't think it does. We'll want an L bracket. And an R bracket. All right, so that's the syntax of a conditional, but we have to fill this and this in. So this one's easy because what goes inside a conditional? It's a block. That part's easy. But what goes inside of here is technically a Boolean, specifically an expression that resolves in a Boolean. But I can technically just say that it is an expression. And all right, there's an ad coming up, but let me see if I'm able to do this fast enough and test if it works. Jesus Christ. This part is the one I waste the most time doing. I'll see if I can make it a little bit better. It parses this, but obviously I don't have a fucking conditional here. Nope, that failed. All right. Statement can also be expression. We're not doing C right now, so let's not worry too much about that right now. But you are right. All right, I'll be back in 3 minutes. All right, we're back. Him too. And okay. First off, thank you to everyone who's sharing resources on my Discord for compiler design. Full disclosure, confession time, I have looked at 0 of them and I intend on looking at 0 of them. I'm just doing everything off of vibes, again, which is why I keep saying vibe coding, but not with AI. You know? With natural intelligence. That is. So everything that I'm doing is just based off of how I know that things work and my previous experience building a compiler, which I also didn't look at a whole lot of resources back then when I first did it. So, yeah. But I like implementing things naively and they mostly work pretty well. So, if I need to, I will look at those resources. But most of the times I'm either asking you to share them in case I do need them eventually, and also in case someone else wants to look at them. But still, thank you for everyone who's sharing resources. Okay. Just added if statements, just added conditionals, but they are not working. But luckily, this should make it somewhat easy to tell what is happening. All right. I should be able to comment all of this out, and it will still fail. And it failed at a different point. But then again, the place where it's failing is not particularly relevant because it is kind of very basic. But it is saying that it is failing at line of character 137, which is like here. But that doesn't really mean a whole lot. So essentially you managed to parse this, but then you failed to parse this. The main difference between a conditional and a function call is the fact that a conditional is followed by a block and a function call is followed by a semicolon. Which again, technically not correct, but very basic implementation of the language. An identifier, a left parenthesis. The function call has an argument inside of it. The other one has an expression. A single expression, which doesn't include ends and whatnot, but we'll include those eventually. Maybe it does, actually. Maybe those work too. I'm not sure. But an expression, a right parenthesis, one ends with a semicolon, one has a left bracket. All right. Yeah, here it is. It matches if with subrule 5. Which one is 5? Let me see if it's doing the right one. 5, I believe, is a function call. No, I want it to be a 7. Rule 7. Subrule 7, here it is. It parses the if correctly, opens the parenthesis, then this succeeds the internals test, yes. Then it parses the closing, but instead of finding token 12, it finds token 10. Token 12 is what? The left bracket? Yeah. It finds... Okay. It's a left brace. So that's the issue. And instead of just recompiling everything, I'm just gonna... There. You're not differentiating between keywords and identifiers? Not really, no. Not right now. It still fails. I did recompile. And I did fix it, yes. All right. Rule 7 fails here. All right. Where's rule 7? Here it is. Parses an if, opens a parenthesis, parses all of this, and that. Goes back to subrule 0, so it tries to parse a block. And this is a pain in the ass. Subrule 5 I'm looking for. That one actually succeeds, I believe. Yes. Subrule 5 is succeeding. After which it tries to parse another statement and it fails with option Subrule 1 option 1 is a statement followed by another statement. That one is going to fail. And it kind of sucks that it is going to parse the statement, but then it's not going to parse the second one, so it's going to start all over again. That's kind of annoying. But that's an optimization for later, kind of. Wait, hold on, this is weird. Wait, okay, hold on. I'm looking for rule 0, option 1. This one's gonna fail. It's gonna try rule 0, option 1. Okay, here we are. It's then gonna try rule 5 and oof. Okay, so this is an actual error. In the entire time, it backtracked to 160. Which is here. Shit. Okay, that's a problem. Essentially, it managed to parse this far, but then after this, it expected another statement. So something like this, or this, or this, or this. It didn't find it, but then it tries to parse from here, not from here again. So that's why it's failing. And this time it's an actual error in the parser, as opposed to just an error in the syntax of the syntax parser. So why? You managed to parse subrule 5. That's right. But backtrack to 160 is not correct. It succeeded up to here. This part succeeded. So, okay, I'm starting to understand. The backtracking. This is the only place where it could have failed. Okay. Okay. I think I'm understanding. No, hold on. Yeah, I understood. Okay, there it is. So now it matched correctly. And I can bring all this back. And it still matches correctly. New lines don't affect it. And this is wrong. On line 130, well, on character 137, it fails. Yep, that is correct. Okay. Cool. So we have all that. All right. Say that I want to write a proper program. We're still not quite there for writing a proper program, but we can give it a try. Yeah, I know. It's very limited right now, the rule parser. This one. It's very limited. I will most likely be doing that. So probably something like this. That's the syntax that I'm going for, most likely. Except that was a function call, so that's not where the if would go. The if would go here. But yeah, that is most likely what I will be doing. And only for uppercase identifiers, but not super important right now. Wait, although... Did I delete the rules that I made? I think I did. Yeah, I did delete them completely. When I made this, that could parse itself. Which one even is recursive descent? Hold on. I mean, kind of. It's just not... the syntax of the rules themselves is very limited right now. I just hacked it together in a couple hours, or an hour even. Like, technically, that's the plan. It's just not there yet. Okay. So I'm able to parse all of these things, and if I wanted to make like a very simple program, for example, then I could do... not really. I don't have labels yet. And without labels... Yeah, but my parser is kind of generalized. Because it's not actually relying on a generator. So if I had to do it like that, I would have to write a lot of code. The generator literally just creates an array, which then my parser uses to parse. It creates this. Whereas a parser like that would benefit more from a more hard-coded type of thing like this one. But that's not currently what I have. Either way, yeah, I don't think I could write a program that would technically be correct, but... yeah, what I don't have is go-tos at the very least, if I want to have that type of thing. I think I should implement them. Yeah, what the hell. Hey, might as well write the damn thing. Which is what I wrote before. I'm blanking on what I should actually write here. What the hell? Alright. This is what I was blanking on, by the way. Why don't you consider this to be valid syntax? What is your problem? It is valid syntax, I'm sorry to say. It is valid syntax. Right, because you can just do this. I guess it's complaining because this is technically not a C file, right? Because it's not inside a function, pretty much. Oh well, cry about it. If I have time, I'll implement functions, but I probably have time for that. It's not super difficult to do. Okay, there's a while loop, then there's an X loop. Then there is an if y is smaller than 100 with a y plus equals y plus 1. And a very similar thing for the X loop, just indented a little bit more, using this with an X. And then here we're just going to create a dummy function called draw, which is going to do, I believe hexadecimals are allowed. So, okay, this is not valid, first off. In terms of correctness, I would call this correct. Just poorly indented, but correct. And then I can put a printf done here. All right, so that is correct syntax, but it is not going to compile because we have this and we have goto. So can I implement those real quick? All right, if I do that, then I'm going to have to add them to the rules here. I'm going to call them jump and label. Jump and label. And you can have that at the beginning of a thingy. You can have a jump. Or you can have a label as a statement. Yes. All right, so jump is actually just identifier. This is where the grammar is really starting to fall apart, as it is right now, without specifying what identifier should go here. So maybe tomorrow I'll add it, because yeah, this is kind of starting to fall apart. Maybe today? We'll see. All right, and a label is just an identifier followed by a, is it just called colon? Colon. All right. That is the syntax as of right now. Yeah, so the parser generator is literally just doing this. So I don't have a whole lot of flexibility with it. Which is why the grammar is technically correct, but looks so stupid. And is also very prone to some really ridiculous code that you can write. Okay, and that failed. Let me try to parse these individually to begin with. That works. Okay. Can you parse this? No, because I actually wrote these if statements without brackets. Okay, that works. Are you able to parse everything now? Nope, still fails. Is it this by any chance? Yep. All right, so I think hexadecimal numbers are not allowed yet, so we're just gonna do color. No, that still fails. Does it only have... Interesting. Alright. So having more than 2 arguments is failing. Wait, did I not make it properly recursive? An argument is an expression, comma, expression. It should be an expression, comma, argument. That's the problem. An argument should be an expression, comma, argument. Now it's able to parse this. It is able to parse this. And it is able to parse this. Amazing. I wouldn't go as far as calling it Turing complete, but Turing would be proud. Yeah, what the hell? It's Turing proud. Not Turing complete, but Turing proud. It's also utterly meaningless because, for example, this is also valid. This is a valid go-to. So, I don't know. I feel like that's not quite correct. Okay. So, let me see what I can do. I have 3 options right now for what to do next. The first is to ignore the glaring issues in my syntax parser, because this is technically a valid go-to statement. Then again, I showed earlier that this is valid C code. That's valid. Because really, it just resolves to this. Or this, if you write it correctly. So, great job, C. Amazing win on that one. So yeah, I can just ignore the glaring issues and build the AST, which is also what I titled the stream. It's been 2.5 hours and I haven't done that. Which is to say, now that we're able to parse a program, and if we even look at this, we can see a very clear hierarchical structure in the parsing of the program. And of course, if we want to do anything else besides this, including code generation, including semantic analysis, then we will need to have an AST. Or we take time to make the generator a little better. I believe that would probably be the best thing to do here. Just make the generator a little better. Well, not the generator, the parser a little better. So real quick, I am going to commit this, even though I don't understand why it was segfaulting before. Genuinely no clue why it was segfaulting before, but there. Just gonna commit this. Since it's been working now. I guess the compiler was still waking up. Like, GCC was still waking up, was half asleep and made a couple mistakes. Oh well. And then, I'm not even using this bootstrap thingy anymore. I'm also not using this, but I gotta make sure that it still parses. Yeah. There's parsers on parsers on parsers in here, by the way. In order to compile the program, we actually need to parse this config file, which is a TOML. And it has this array, and the array has a CSV parser inside of it. All of that to then parse, to then run the compiler, which itself is, well, to compile the compiler, which then runs, which then parses using this, which is generated by this parser. So, yeah, the guy who created the tokenizer scanner and all of these classes, thank you. He saved me like a ton of work. Like literally everything is now relying on them. Everything that I've coded in the last, well, in all of 2026 is literally all of it relying on the tokenizer, scanner, and all those classes. Okay. So yeah, I think the right thing to do here is to make the rule generator a little better. Which is to say, to parse specific values and to yeah, to parse specific values. That's pretty much the main thing. And second, maybe I can move this out of here, out of this file, put it in its own file, and then the rule parser can directly write to that file, which would be much faster in terms of generating new grammar rules instead of having to like copy from the terminal and paste in here. All right, let me start with that one actually. I feel like that's faster. Hopeful. Wait, no, hold on. Have I actually implemented file writing? I have not. Why am I writing like this? Write full file const char path const char content. Wait, come to think of it, writing to the console is simple because I'm just calling print. Whereas what I'm talking about right now, it requires a lot more work. So yeah, let's not do that right now. That is definitely not the biggest issue that my compiler has right now. The biggest issue that compiler has right now is the fact that a conditional should be written like this. What else? What other ones? Assignment is fine. Function call is fine. Declaration is fine. Although it would be nice to now be able to do this. We'll see, we'll see, we'll see. Jump. This is go to. Any others? I think right now, no. But once I start introducing like while loops and all those things, they will be, but okay, I think these are good. If I try to parse this right now, what the fuck did you just do? Oh, it considers them to be rules. Right. Wait, so that's actually super simple. That is actually going to be incredibly simple to parse this. Because I just realized this parser looks for this. So what you want to do is if the token kind is token string, then you're not parsing just an identifier. You're parsing that, which is not valid syntax in my parser, but it will become valid syntax in my parser. I'm just going to call it const, actually, and just do it like this. No, const is not right, because there's already a token called const, so that's going to be kind of hard to read. Literal. I'm going to call it literal. All right. So you can now have a literal go-to, token identifier, token semicolon, all that stuff. Cool. That was super simple to do, actually. I thought it was going to be a little bit more complicated. Not super complicated, but I thought it was going to be a little bit more complicated than that. So that's for the rule generator itself, but of course, literal is not an actual thing. I haven't actually implemented it. But even that should not be too difficult. It is a rule with a value, and I can support literal values, which are 0 by default for these, but for the literal val, then it is not a rule. It expects a token identifier with val as its value. So that works now, and technically my program should still compile and work as always. Yeah, but it still compiles with clearing issues because it doesn't check that the identifier actually matches the value that it should. So that should be pretty easy to do too. Here, where you're parsing the token, all you're doing is checking if the kind is the one that you expect. But now we're going to add a new condition, which is that either the element has no literal value, or if it does have a literal value, then the token then the token matches that, which we do by str start with the token start against the element lit is equal to the token length. So it checks if it matches, and now it will fail. If I go back to making this a go-to, it works. That was actually surprisingly easy to do. What did that take me, like 5 minutes, 10 minutes? That was surprisingly easy. I was not expecting it to be that easy. I'm a little bit surprised by how easy that was. Okay, wait, there are more places where I'm technically not doing things correctly. Like wherever I use an operator. Here, for example. No. Technically not. But like, I made a sign, instead of being an operator, it is now its own token. Whereas it would be cooler if you could do this to say it's an operator and it has to match this value. Right? The compiler is already ready for doing this. The parser is not. The compiler, all it needs to do that is a new one of these definitions. Similar to the literal, but instead it is a lit token that just works like that. Right, and then Yeah. Now, specifically, if it is capitalized, yeah, so hold on. If it is capitalized, which indicates that it is a token, then we need to check, do we have another token after it? So we kind of have to do this. Wait, no, that's not right. That's not right. This goes outside of whatever condition I end up writing in here. Okay, so if we're here, we've technically found this, right? And next we have to parse this. So we want to parse a parenthesis, we want to parse a string, and we want to parse another parenthesis. So I want to parse that. And P1 kind is a token left parenthesis. And the same condition for the second parenthesis. This feels a little bit more complicated than it needs to be, but hey. And then this one is a token string. The S is a token string. Then, hello, Baha. We want to parse this as a T lit talk V, comma, V, where we put whatever we found and then the string. So token to slice string. Okay, I'm not entirely sure that is going to be correct, but there is only one way to know. Yeah, I detected this as a rule, so that's not right. that is super wrong. Oh god, it broke. Where's the first time that I do it? Here in the assignment. Identifier operator equal. In the assignment, identifier. Then it found the rule parenthesis. Yeah, that's not right. Compiler from scratch in this economy, yeah. Oh, wait. Okay, I hadn't considered. TS next is actually consuming the token, which means this one could work, but not this one or this one, and then it will... Hold on. That was never gonna work because I never changed this condition. Mostly it's just... I don't even know why exactly I'm doing this, to be completely honest. I have a lot of reasons why, but... I'm not trying to replace C or anything like that. I'm just trying to make it compile whatever I need. What was the first one? It was assignment. So wait, we already made it past assignment. Yeah, this is still parsing wrong. Yeah, I guess C. Or a superset of C. But right now it's actually a subset of C. Because technically this is valid C syntax, right? Hold on, let me see. Yeah, might as well. My compiler doesn't even work right now. So now's the perfect time. It complains about the fact that I didn't rename this and that printf doesn't exist and draw doesn't exist, but besides that, it is valid C syntax. Cool. Just very limited, but it is valid C syntax. It also doesn't go within a function, so there's that. Okay, I'm still not sure if next is actually advancing. I think it is. And I'm not writing this correctly. That's not right. But I don't think that's the problem. Yeah, that's not the problem. Yeah. To be fair, I'm not trying to bootstrap it compiling itself anytime soon. I'm actually not gonna touch the syntax once I'm done with what I'm currently doing. I already have technically something that is mostly kind of Turing complete. Mostly kind of because like any kind of writing to memory in this case would be handled by this draw function. Right? But technically it's there. But I just want to move on to you know, actually generating, well, not generating code, just like generating the syntax tree. Okay, again, jump, label, okay, this is good. Then identifier, and then it completely breaks here. It thinks that the rule is this, the parentheses, followed by literal, which is wrong. Yeah, so it's not parsing them correctly. Yeah, because this is consuming the next token even if it's not the right one, so that's just gonna lead to an offset. Is it peak? Yeah, but damn it. Ooh, we have to backtrack here. I guess it's not too complicated. I have access to the scanner, right? No. But the token stream has access to the tokenizer, which has access to the scanner, which has access to the position. And that position is an int32, uint32. And if you fail to parse a literal, then you backtrack. By just setting this variable back. That looks a lot better, I would say. Yep. Yep, 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 yep. This was actually surprisingly easy to implement. I thought it was going to be a little bit more complicated, but hey, not half bad. Now if I run this, it should have failed. It definitely should have failed. I'm pretty sure it did fail compiling, and so it ran the old version of the code. Jesus, that's a lot of... Yeah, it failed compiling, because it doesn't even have a comma here. lit talk. I also put them backwards, so maybe that was not the best, brightest idea. Yeah, they should have a comma at the end. Yeah, about writing this to a file, I feel like I'm just going to wait. Most likely I'm going to take a little detour to create a file formatter, code generator type of thing sooner or later when I continue working on this. So actually probably after the AST, I'm not even going to bother with what is it called? Semantic analysis just yet. Because probably the first iteration of this compiler to be considered working is to just compile C++ to C, since the way that my C++ is structured is incredibly similar to C because it used to be C. So considering I already know that it is semantically correct, I might be able to get away with just making a code generator. Essentially take the abstract syntax tree and turn it into code. Obviously skipping a bunch of steps, but kind of the same thing that this rule parser is doing. And if that's the case, then I will be able to go straight from, to create a code generator and proper formatter and whatnot, and make it so that we can automatically generate rules for the compiler to pick up. So obviously, now that I changed the code, an equal sign is no longer being expected. We expect an operator which has the value of the equal sign. We don't expect the equal sign as a token itself. So I'm not sure if I made it configurable or not. I think I didn't. Parse new line, comment type, and skip type check. I did do that. Bye, MX. But no, what I did essentially is the equal sign. I made it so that it no longer counts as an operator. It is instead its own token. So I need to undo that now. Pretty much get rid of that. That's going to create an error here. And I can just remove this special case, at which point I will need to rebuild this library. Toml was expecting a code generator though. I mean, an assignment, not a code generator. So, Toml, here you are. Operator or operator dot, I have to write this whole string start. Like, can I just write a, all right, I need to compare the value of operator to an equal sign. But tokens work with string slices, which are kind of new. And I haven't implemented a way to make these string slices match, like to see if they match something. So I'm just going to make it highly specific to what I'm doing, because I'm kind of hacking it together here. It's literally just the string start, checking that the slice data and the literal value is equal to the slice length. All right. So that function should help me write these types of comparison a lot easier. As now I can just do, I'm in the wrong project. I actually did the same thing here, didn't I? No, here. Here I can just do slice lit match between the token to slice of the token, just the token, and the literal value expected by the element lit. Like that. It's actually longer than what was there before, but that syntax can be a little bit confusing, so I find it easier to write. All right, and back to what I was doing before, which is the TOML parser. If no slice lit match between token to slice OP and literal equal sign, then you return. Yeah, so TOML expects an identifier with an equal sign, and that seems to work. Hey, let me see real quick. Yeah, that's a no. That's a no so bad that it actually just has a black screen. Jesus. If it's not an operator, or if it is an operator, but this doesn't match, then hold on. Maybe it is easier if I just do it with what I've been working with so far, which is this. I'm not entirely sure what the hell just happened, but the compiler just ran this and was like, yep, good enough. Int y, that's a valid program to me. So it literally just parsed this, and everything else after that, it just completely ignored because this failed. So I most likely wrote this condition wrong because this is the first one that's failing. What I'm surprised by is that it doesn't go into the else. It just fails and it's like, yep. Why? What was the condition that was there before? This, right? Just the same as SL data. Then the literal value lit equal to the length. And that was working, right? Just to be clear, was that working? No, this was also failing. Whoopsie. Didn't notice. Not a rule. A token of type tuck with whatever value. Operator equal. That should be correct. All right, let me keep debugging this after the ad. I'll be back in 3 minutes. Okay, we're back with a compiler that doesn't work. Yay. It's so weird. It parses 2 tokens and then it's like, yep, that's good enough for me. It parses this, and then it reaches this and it just completely fails. So what could possibly be happening here? Well, we can always go back to this, except token assign doesn't exist anymore, so... Well, you know what, maybe I'll clean it real quick. Except that doesn't do anything, I just remembered. Besides this warning and this note... And this one? I don't get it. It parses these two and then it exits, but it exits successfully. Which, like, shouldn't happen. Unless it ran out of Hmm. It might have run out of characters here or something. I don't know about the name yet. Right now it's called cred because it's C red, but technically we're just going for C just now, so I'm not sure yet. All right. What's so incredibly weird about this is that it parses 2 correctly and then it just doesn't do anything else. It just stops there. It doesn't even end the sub rule or anything like that. No error, no nothing. It's not even... Yeah, I just cannot find the next token, that's it. That is so weird. Okay, let me do token operator. The last time this worked. So what changed since? Besides literally everything in the code in the last like 10 minutes. Can you parse this? Yeah. Including these assignments over here. It parses them correctly. It parses these correctly, so how can it not parse the other one correctly? I'm so confused. Are you serious? Did it just work? No way. Oh wait, these are not there. Okay, so it did work. But then... Right, what if I just don't do that and I just do this instead? I am so confused. Because it works here. Wait. No, it doesn't. It just manages to parse a little bit more. It gets to this point and it just dies. Completely. What the hell? Okay, so it gets here. It parses. It then goes into this function, which goes to the next part of the sequence. This parse token is being called by whom? Just by this. And then this fails. So whenever it encounters an equal sign, it just dies. Because this function must be failing. So the problem is here. Can I bring this back real quick and do a git blame? Can I see this commit? There it is. That's what's missing. Okay, so the tokenization is failing because I never registered the equal sign as an operand. That's what's happening. As to why it fails silently like that? IDK. Probably shouldn't. Okay. That feels better. It parsed done, so that means it actually is done parsing. Okay. There's gotta be some sort of error state that I'm not looking for in the tokenizer. I'm not sure how to look for it. Kind, length, pause, and start. Okay, what about the tokenizer itself? That's probably how you do that. I don't know, but that's probably how you do that. I also don't know what a tokenizer error looks like. Error none is 0, so that's perfect for me. Alright, so if I go back and I remove this from here and I recompile the operating system, well, the library, and I run this, tokenizer failed. Okay, that makes more sense. Now if I bring this back, I recompile this, and I recompile this, it actually works. Okay. I'm going to remove this again and this as well. So then the entire thing looks like this. Cool. Alright, compiler's back.
Good evening, Mr. Programa. KR0MBUS subscribed to your channel for 6 months.
Grumbus, thank you for the subscription. I had to read the message because the Spanish accent made it difficult to understand, but thank you for the subscription. Hello, Grumbus. Alright, so officially, parser works, and I want to see if this works. Okay, this is back to working as well. That's good. It was kind of broken, but now it actually parses TOML files. Parse this one correctly. Parse the one. Yeah, that's good. All my French skills in 2 words. Okay. All right, so I added this. I added this. I removed this. I removed this. And I did this. Then I also did this. And that's it. And tokenizer. This is valid syntax for what exactly? I'm not sure, so I'm just gonna write it like that. I still don't know why I'm labeling all my git commits with that format, by the way, but I am. And someday it's gonna come in handy. I'm not entirely sure when that day is. Alright, I definitely gotta commit everything that I just did because I've done a lot. And yeah, none of it is here. But I'm just gonna quickly take a quick glance at the code, see this part should be gone again. Come on, man. Let me edit. Oh, wait. Yeah, okay, never mind. I was trying to edit code that was removed. That's why it didn't let me. Okay, that's good. Yeah, get rid of that. Yeah, that's good. Kind of both at the same time. Also, mostly C compiler. With a C++ parts of C++ because the C++ that I've written is C style C++. That's pretty much the only reason why I want to have that language. Also, hold on. This should be back to being slice lit match token to slice token and literal element literal, like such. Okay, all right, okay. Okay, so for the language, I added functions, jumps, conditions. Then for the parser, wait, for the rules, literal identifiers, and I also added, well, just literal tokens. For the parser, I added indented debug logs, and I also added tokenizer error check. That's a lot of stuff. I should have done a million commits, but all right, there we go. Now that I've done that, I can write a rules.c, and I can move this into it. Which requires me to define this thing. No, not that thing. All of them, actually. And these definitions. And these xenums. So rules.h. I have all that in there. Pragma wants it with types.h. All right, that compiles. And it should also define an extern of this. Then you should include rules.h. That way you should be able to compile, but you're not. Because? Yeesh, that's not good. Tuck identifier. Oh, okay. I just bring the tokenizer in to the rules.h thing. And now it should work. Yep. And you should no longer use these grammar rules anymore. You should instead include rules.h. Okay, cool. So I am not going to make this parser here write to this file directly just yet. Like I said, soon enough we'll be doing code generation, and when I do that, it's gonna look a lot better to do that. So I cannot be bothered right now, but at the very least, I have it here, so I can just very quickly just do this and this with whatever I copy from the terminal. And to make it even better, I can actually just do this. Does C have these type of strings? Not really, right? But it does have these. Not really. Okay. Well, that's a to-do for my language. But anyway, I want to include this at the very beginning of the rule parser. Just going to require some formatting. And this at the end of it. And if I'm not mistaken, the indentation is manual here. So that is kind of a pain in the ass. But like I said, I'm incentivized in making a proper code generator. So I kind of don't want to bother with it right now. That's wrong. File in the wrong format. Hold on. All right, so now I'm able to just do this and that. And then do this and that. And that properly parsed my language. My language is a strong word, but again, it is capable of doing anything that C needs to do, just in a very simplistic manner, and writing to memory directly using this function here. But hey, if you make a code generator that actually draws the calls this function, you're good. Like, my plan essentially is to, after it's able to parse this, it should be able to turn it into a tree, then do semantic analysis on it just to make sure that everything is correct. And we're not going to do anything particularly complex because the code generator, after that is going to come code generation, and code generation is going to be C. It's going to generate C code. And once it does that, then it will be able to rely on GCC for the actual compilation process. And so, for example, I can just create a draw function. And when I'm doing the code generation, I'm just going to do include, I don't know, helper.h. And that's going to contain the draw function and the printf function and all that stuff. So that's the cool thing about hacking things together. It's simple. Okay, but to do that, we need to have an abstract syntax tree, which I'm thinking I can leave for the next stream, because it is kind of late, but I'm not. Okay, I don't know why you think that this is not being used. I might keep going for a little bit. But before I do that, and that. Wait, what did I change in main? Oh yeah, of course. All right. Okay, about the syntax tree. Let's see. This is the grammar that I'm currently parsing. And I'm pretty sure it's actually so simple that every one of these is being used by this simple program right here. Let's see, function call is there. Expressions with operands are there. Declarations are there, jumps are there, labels are there if there's jumps. Expressions are there, conditionals are there. Arguments too. Function calls, if there's arguments, obviously just function calls. There are assignments, statements, and blocks. Yep, pretty much all of it is there. Damn, that was surprisingly exhaustive. So pretty much each line of code is a rule. Well, not really. Not really. That's not true at all, actually. What the hell am I talking about? Yeah, I'm not entirely sure what the fuck I was gonna say with that. That's entirely wrong. The thing is that rules are recursive. So you start with actually, for example, the function call, right? You have an identifier, a parenthesis, an argument, a right parenthesis, and a semicolon. By the way, semicolon shouldn't go there, but not important right now. So yeah, identifier, open parentheses, arguments, close parentheses, semicolon. This is a subrule. And if you look at this, it's incredibly clear how it's all hierarchical. And because it is all hierarchical, we should be able to transform, or not to transform, but to represent our code into or with an abstract syntax tree, which is... Where are you at, buddy? I know you're here. This thing right here. Right, where this is a conditional, for example, you have on the left side, or the first node of the tree is the expression that goes inside, whatever that may be. Right, so whether your if statement looks like this, or it looks like this, well, that's actually a very simple one. This very long one, for example, or hello? How did I not realize that? So that actually hadn't compiled for a while. I didn't even notice. God damn it. Yeah, this one, which has nested elements inside of it. The syntax tree looks the same. We have the expressions inside of it and the block here. So all of this inside and all of this in the second element, and this nil here represents a potential else that you could have. Right, and again, if we look at the structure that is generated by the debugger, by the printf debugging, you can very clearly see the tree syntax that is happening here. But of course, it's not actually generating any of it. It's not keeping any of it in memory, so we cannot do anything with it. And that's a little bit of an issue. So I'll need to create the syntax tree. Most likely, I'm just going to define what it looks like right now and just implement it tomorrow, but I guess we'll see. First thing I should do is amend this commit and pretend that nothing happened and just force push. There we go. Absolutely incredible work. Okay, y'all are very quiet today, by the way. Okay. What information do we need the syntax tree to keep? We need to know what kind of statement is being made. So we need to know the rule that's being parsed as a result of the tree. For example, let me write not all this, because this is a lot of code actually to represent in a syntax tree, but let's just say this, right? This is my code that I'm going to manually parse here. Where's my compiler stuff? Here. Right. Okay. So this is an if statement, right? So that's parsed by the conditional rule. It's an if with a left parenthesis, a right parenthesis, a left brace, a right brace. So this, and this. Inside of it are an expression and a block. The expression is this one, the block is this one. So, the way that this is structured is just conditional with the expression and the block. there's no need actually to keep the if statement, right? That is not really necessary, as long as you know that it's a conditional. But in a way, it is necessary because it's equivalent to this, right? So you could just have like if, which is the same thing that the one in the Wikipedia thing had. The expression, which is y smaller than 100, and the block, which is go to y loop semicolon, need to be parsed as well. So this expression is very similar to, again, what was on Wikipedia. This with the y on one side and the 100 on the other. And the block is actually incredibly simple. It's just a goto with the y loop. And we can imagine that there's little things here. So essentially, we can get rid of some useless characters that we don't care about, such as the opening parentheses and opening brackets. These are important when you're writing code because obviously they indicate where your code starts and ends. But once the compiler has already picked up on where the code starts and ends, then you no longer need to keep those characters anymore. They're essentially replaced by this and this, kind of. If we want to get a little bit more precise about what's actually going on here, I just realized I have this bookmark. Get out of here. I want to be a little bit more precise. This is an expression that's being parsed here with just one element in it, which is this one. And this is a block. Which then would have that. So what important information do we need to keep here? First off is the token itself. In some cases, like the Y token is important, the 100 token is important, the comparison token is important, the Y loop token is important, but the goto token is not. This is technically saying, hey, there's a node here with goto, and it has a node with the token Y loop, but the token of the word goto itself does not need to actually be kept. In the same way that the if statement is used to indicate this is a conditional, but the string with the if statement inside of it isn't actually necessary to keep. But I'm thinking about what data needs to be represented by this thing. Everything right now is happening inside of the this one simple 144 line file. So that's incredibly simple, but it probably shouldn't all be in one. But really the only difference is that what I'm writing here is going to move over to a file called parser. I can do that off stream. I don't care about that right now. Okay, so what information does my AST need to keep? it needs to keep track of the token. And the rule that was used to parse it. Is that enough information? No, at the very least, it needs to also keep track of the option that was used to parse it. In addition to the fact that they need to be recursive, but I'll introduce the recursion later. Is this enough information? Let me see. No token here. Option 0, there's only one. Well, rule conditional. Well, maybe we'll still keep track of the token because we already have it, so we might as well keep track of the token. Then for the expression, for example, it uses option 1, I believe. Because expression can be chained. So I can just do that. And then block, it's probably option like, I don't know, 5, 6. Okay, I should probably research the best way to structure all of this and the information that I need to keep a little bit more. Because right now I do feel like this is enough information to go off at the very least for a basic syntax tree. But I'm not entirely sure. And most importantly, we are working with C, in which you have to be very explicit about allocations. And so making it recursive, like a tree structure, is a little bit of a pain in the ass. Especially when you consider the fact that you can backtrack a lot. And that is the part that really sucks, because it probably means allocating and then deallocating if I realize that it's not correct. I'm not sure. So yeah, I'll need to study, first off, what information do I need for an AST? And second, the best way to structure everything in terms of like memory. But the overall logic for it, we already have, but I'm gonna leave the actual AST for tomorrow. I'm now gonna work on this after I'm done streaming, because first off, the next stream is in like 13, 15 hours, kind of. And second, because if I switch to my laptop and it doesn't work and I need to make a bunch of changes, and then I switch back to this and it doesn't work and I need to make a bunch of changes like I had to do this morning, I'm gonna go crazy. So since I am streaming tomorrow and Sunday and Monday, I'm most likely just not gonna work on the compiler on my laptop in between. I've also restarted working on the hacking game, so if I do anything, it's gonna be related to that. Okay, so that's gonna be it for the stream today. Tomorrow I'm going to build the actual syntax tree once I am a little bit clearer, mostly on the memory layout of it all. Because the way that I'm thinking feels kind of ugly. Not even inefficient, just ugly. So we'll see. We'll see what I decide to do. Or how I decide to structure it. For the time being, I'm keeping this very basic structure for it in here. And tomorrow we will decide what this tree looks like. And once I have the tree built, the next step is semantic analysis and then code generation. The thing about it is that the rules are literally just in a text file. But then the actual semantic analysis is based on some more complex rules than just this. Because these are rules for a parser, right? So expect to find I followed by f, followed by a left parenthesis, followed by an expression, followed by a right parenthesis, is somewhat easy to express in text like this, and then you literally make a generator that generates your parser. That's pretty simple. But when it comes to semantic analysis, you cannot do it in like, yeah, I don't even know how to express it in text. It has to be in code. So that part is going to be hard-coded. And so it's a little bit awkward that this part is not hard-coded, but that one is. Yet at the same time, this part, the rule declaration is hard-coded. What they look like is different, but the rule declaration itself is hard-coded. So I guess I'm taking a little bit of a hybrid approach already between hard-coded and dynamic. So it maybe won't be too much of a problem, but yeah. We'll have to do some very basic amounts of semantic analysis just to make sure that you're not writing anything absolutely ridiculous in your code. And then we'll be able to do code generation, which means that we'll be able to, well, actually generate C code, whereas my syntax is technically valid C code. So it's actually kind of funny how I said that, oh, we don't need to keep the brackets and the parentheses. We don't need to keep them. But when we're generating the code, we'll write them. So we're going to parse them, we're going to discard them, and then we're going to write them again. So that's going to be fun. But once we have all that built, I can start playing around with the syntax a little bit and making it a little bit more modern. Include a couple interesting things. And we'll have the basics of a compiler built. Okay, but that's starting tomorrow. I've been streaming for nearly 4 hours already, and I do need to figure out a little bit of the memory layout of the tree, so that then I can move on to the next parts. All right, so spoiler alert, the actual C compiler is going to be doing all the heavy lifting in the semantic and actual code generation parts. All right, thank you so much, everybody, for watching. Tomorrow's stream is at 3 p.m. It is currently 11 p.m. So it is at 3 p.m. Central European time and 2 p.m. UK time. So it's an afternoon stream tomorrow and Sunday as well, where I will be working on the compiler for both of those days. And I'm going to work on a window manager on Monday, same time as today, so 7:30 Central European time. Because, of course, while operating system development is continuing kind of behind the scenes, I still want to do it on stream as well. But honestly, the operating system is in a pretty stable state. and I'm kind of wanting to focus more on making it stable rather than adding new features to it. It's doing good when it comes to features. I added a window manager, which I thought was, I improved the window manager, which I thought was interesting. After that, I'm going to focus a lot on stability, which is not going to be super exciting. It's mostly just going to be this. Maybe with a little bit of GDB here and there, but I'm going to try to not use GDB as much as possible. I'm probably going to develop some debugging tools and whatnot. And who knows, maybe the compiler is going to turn into a static code analyzer. Actually, that is a plan. Though I don't know much about code analyzers, but that is kind of a plan that I have. So yeah, that's the plan for this weekend. Probably going to be AST, semantic analysis, and maybe starting on code generation, and then window manager on Monday. And yeah, thank you so much, everybody. I will see you tomorrow.